Okay, I'm going to show you some examples of what we're seeing in this lesson for 2. And the first thing we need to know to add rational numbers is pretty much the same thing that we see the past lesson 3. We need to find the additive inverse. Remember, the additive inverse of a number is a number that will help us get to 0, back to 0. Okay, so in this case, in order for us to graph it, if right here we have 7/8 that way, we should have 7/8 this way, right? So my graph should look something like that. So the opposite or the additive inverse of negative 7/8 is 7/8, positive. Okay, this is pretty easy. If we have a positive number, it will be a negative number. If we have a negative number, it would be a positive number, right? Let's see the next example. In example number 2, it says find additive inverses. Annalise earned $36.82 at her part-time job, and she earned $18.50 babysitting. Find the total amount she earned, the additive inverse, and describe a situation so that Annalise ends the week with $0. The first thing we need to do is to find the total amount she earned. And in order to do that, we just need to add what she earned in her part-time job and what she earned babysitting. We express this with algebra using a P for part-time job and B for babysitting. So the total would be a simple sum, okay? We'll do a sum. Remember that when we are adding with decimal points, the decimals should be in the same line. So I'm going to do the addition right here. 36.82 plus 18.50. The decimal points need to be in the same line. So 0 and 2 is 2, 8 and 5 is 13, we have 1, and 7 and 8 is 15, we have 1, and 3 and 2, I'm sorry, 3 and 2 is 5. So the total amount she earned right here, it's $55.32. All right, so what we need to do, the first part, it's only find the total amount she earned. In this case, $55.32. Good. The next part tells us that we need to find the additive inverse of that number. Okay, so she earned $55.32. This is positive because she earned them, she gained them. Okay, so the opposite inverse, it's what makes her lose everything in order for she to have $0. So this is pretty easy. We only have to use the additive inverse of that number. In this case, negative $55.32. Okay, good. Now, part C tells us, describe a situation where, so Annalise ends the week with $0. Circle the situations that represent negative $55.32. So what are situations that represent negative $55.32? Losing $55.32? Yes, right? Because it's a negative. So if she loses them, it will be negative $55.32. What about finding? No, finding it's obtaining, gaining. So that will be positive. Donating would also be a negative because you're getting rid of the money. Okay? Getting a gift, that's positive because you're earning, you're getting something. Earning, you're getting money, so that's positive also. But spending, it's also a negative because you're getting rid of the money. Okay? So this 3 will be situations that represent negative $55.32. Part C tells us, describe a situation so Annalise ends the week with $0. We could say that she went shopping with her mom and she spent $25.32 in a blouse and $30 in a pair of jeans, right? So at the end of the week, she gained $55.32 by working, but she also spent $55.32. At the end of the week, she has $0, right? Good. Let's see another example. In this example, we're going to add rational numbers. And we have 2 fractions. But if you see the fractions right here, They are mixed fractions. The first thing we need to do is we need to make this mixed fraction into an improper fraction. And we have the right here in your book on page number 188. We have the steps that we need to follow. Okay, so the first thing that we need to do is rewrite the mixed number as an improper fraction. Remember, in order to do that, we have a -3/5/9. We need to multiply the 9 times the 3, and we need to add the 5. So we do it. 3 times 3, 3 times 9, it's 27. Plus 5, it's a 32. And we leave the same denominator, 9. Since it's negative, we also need to keep the sign. That's very important. Don't lose signs during the process. So this fraction, -3/5/9, it's equal to -32/9. We need to do this exactly the same thing with the 1 to 9s. We multiply 9 times 1, 9, plus 2, 11. So we have 11/9. We leave the same denominator, okay? Now, we have them all written in improper fractions. What we need to do is we only need to add or subtract the numbers on top, okay? Add the numerators and assign any negative signs to the numerator. So we have a negative right here. We assign it to the first number. -32 plus 11. Remember, whenever we're adding, if we have different signs, like in this case, we need to subtract and leave the sign from the biggest number. In this case, -32 plus 11, I subtract. 32 minus 11, it's 21. And since my biggest number is a negative, my result will also be a negative. So it will be -21/9. Now what we have to do, is simplify. 21 can be divided by 3. 3 times 7 is 21. And also the 9 can be divided as 3. 3 times 3, it's 9. So we divide it and still have an improper fraction. So we need to see how many times can the 3 go into the 7. It can go twice, right? So 2 times 3 is 6. How many do we have left to get to the 7? It's only 1. So it will be a -2 1/3. Okay? Remember, if it's negative right here, it continues being negative until the end of the process. Good. Let's see another example. We need to add 1/3 plus -1/6. The first thing we need to do is we need to write this mixed fraction into an improper fraction. Okay, so 4 times 1 is 4, plus 3, it's 7, 7/4. I'm going to put it over here on the other side, 7/4 plus -1/6. We have a little problem right here. If we see the denominators are not the same, this means that we need to find a multiple for both of them, okay? The least common denominator. In this case, the least common denominator for both of them is 12, right? Both of them are multiples of 12. So if we multiply this one by 3, it will give us 12. So we need to multiply the denominator by 3, but also the numerator by 3. So 3 times 7, it's 21. We have it right here. And 3 times 4, it's 12. Good. And we also need to make this denominator a 12. So what do? We multiply by 2. Multiplying by 2 will make it 12. 6 times 2, it's 12. And 1 times 2, it's 2. Okay? So we have this with its common denominators. What do we need to do? Once that we have the same denominator, we need to graph the numbers. The 21 is positive, so we put a positive right here. plus 2 over 12 will be a plus negative 2. We're getting only the numerators on top. Remember that we have to assign the signs to the numerators. So it will be 21 plus negative 22. 21 plus negative 20, negative 2, I mean. Remember, whenever we have two signs together, we have to make it only one sign. So it will be 21, and we multiply the signs. Positive times negative is negative 2. So 21 minus 2 is 19, okay, which would be 19 over 12. Or how many times can the 12 go into the 19? It can go one time, okay, and we have left 7 12ths. This one can be our answer. Just write it as a mixed fraction. So the sum of negative 3 9ths plus 1 2 9ths is negative, oh, I'm doing another one. So the sum of 1 3/4 plus negative 1/6 is 19 over 12, or 1 7/12. Okay? Good. Let's continue with the next one. In this one, we have fractions and decimals. So what do we need to do? It's because the addends are written in different forms, you can first write them in the same form. The decimal form of negative 2.5 is a terminating decimal. So you can either write the addends as fractions or as decimals. In method number 1, we write both addends as decimals. So negative 2 over 5 is, let's do the division. Okay, what is negative 2 over 5? 2 divided by 5. Okay, my answer would be negative since it's a negative. Okay, so how many times can the 5 go into the 2? It can't. We had the first 0. How many times can the 5 go into the 40? The 20, I mean. It's 4. 4 times 5, it's 20. And 20 minus 20 is 0. So right here, we'll have a negative 0.4. Okay. And we do the math. Negative 0.4 plus 2.3. Remember, since it's an addition and those numbers are negative and positive, we need to subtract them. 2.3 minus 0.4. And my answer would be positive because at 2.3, it's bigger. So 3 minus 4, we can't, right? We need to ask for a loan from the 2. So it will be 13 minus 4 is 9. And 1 minus 0 is 1. So my answer is 1.9. Okay, that's what we do. The other method is to write them both as fractions. What is a 2.3 in a fraction? 2.3 is 2. It's right here is just a whole number. It will be like a big number. And 0.3, okay, 0.3, it's written as 3 over 10. Since if you see here, it's only one place from the decimal point, so it's a 10th, right? We called it a 10th. So 10ths are divided by 10, okay? Good, so it can be written as 2 whole numbers, 3 tenths. So what we need to do is we need to add them up to 3 tenths. First of all, I need to make this one an improper fraction. 2 times 10, it's 20, and 3, it's 23 tenths. Okay? And this one right here, I can make it also tenths. How can I do it? If I multiply the 5 times 2, I'll get a 10. Okay? And I have to multiply it 2 times 2, 4 as well. 2 times 2 is 4. And it should be negative. Okay? Now, I have a negative 4 over 10 plus 23 tenths. Okay, we do the same thing. We do -4 plus 23 over 10. Since right here I have an addition with positives and negatives, I need to subtract. 23 minus 4, it's 19 over 10. It will be positive because it's the biggest number is the 23. So -19 divided by 10 is, how many times can the 10 go into the 19? It can go once. And we have left 9 over 10. Okay, which is pretty much the same as 1.9. Right? Very good. I hope you don't have any questions. If you do, you can see this video again and again and again, as many times as you need. And for the last example, it's pretty much the same thing. Right here, you have everything you need to do. Okay, it's written by steps. Okay, everything is written right there. Good. So I hope this video helps you. Remember that if you need extra help, you can call me whenever you want, or you can come to my classroom or come to my class. Right? Have a good day or night.